The first method we're going to talk about for solving systems of linear equations is what's called the substitution method. And this is based on the substitution principle, which says that if two things are equal, I can use them interchangeably. Right, so that's what I'm going to do here. This first equation is already conveniently solved for y equals 3x plus 4. So this is saying I can replace y with 3x plus 4, and I haven't changed anything. So that's what I'm going to do. I'm going to take this 3x plus 4, and I'm going to replace that y with it. And if I do that, this equation becomes 3x minus 2 times 3x plus 4 equals negative 11. And look at what happened, right? I eliminated one of the variables. Now I have a linear equation in one variable, and we already know how to solve these. So let's distribute the negative 2. This becomes 3x minus 6x minus 8 equals negative 11. We'll combine like terms. Minus 3x minus 8 equals negative 11. Add 8 to both sides. Minus 3x equals minus 3. And then divide by negative 3. X equals 1. All right, that's awesome, but we're not done. Right? We're not done because we have two variables in the equation, so I'm going to have two numbers in my answer. Right? I've got the x value, and that's great, but I still need to find the y value. So what I'm going to do is I'm going to substitute again. I'm going to take the first equation. It does not matter which equation that you use for this step. You can use either of the two. I'm going to use the first one because I know I'm looking for a y value, and that one is already conveniently solved for y. So what I'm going to do is I'm going to take x equals 1, substitute it into there. This becomes y equals 3 times 1 plus 4, which is 7. And there's the other half of my answer. Right now, you're not done at this point. I always tell my students, at this point, you are not finished. You've done a lot of calculations, and that's awesome, but you haven't answered the question yet. The question is looking for the solution to the system. Right? So the solution to the system, I would say, I would put these two together and say the final answer is 1, 7. So let's take a look at this one here. This one, neither equation is already solved for one of the variables. They don't have y equals and I don't have x equals. But that's okay. I'm just going to have to do that myself. Now, when you're doing this, pick carefully. Right? For example, I am not going to try to solve this first equation for y. You can. And again, this is the point I want to emphasize. You absolutely could do that, and you would end up with the right answer. But trying to do that, I'm going to have to divide by 3. Let's do it real quick just to see what happens. If I move the 2x over, this becomes 3y equals 8 minus 2x. Then if we divide both sides by 3, this becomes y equals 8 thirds minus 2 thirds x. Now I have to substitute this thing with all of those fractions into the other equation and try to solve it. Could I do that? Yes, but it's going to be a bit of a mess. Right? I have a better choice. Look at this second equation. I can solve that one for x without introducing any fractions into the process at all. I'm just going to add 4y to both sides. And this becomes x equals negative 7 plus 4y. No fractions. It's still nice, clean, simple integers. Right? So now I'm going to take this, and this is an important step here. I'm going to take this and I'm going to substitute it into the other equation. It absolutely has to be the other one. If you substitute it back into the one you originally were working with there, you're going to have a problem. Right? So I'm going to take this 2x plus 3y equals 8, and I'm just going to write it over again down here. 3y equals 8. And I'm going to put negative 7 plus 4y in here for x. So this becomes 2 times negative 7 plus 4y plus 3y equals 8. And now it happened again, right? We're down to one variable, so this is awesome. Let's distribute the negative 2, negative 14 plus 8y plus 3y equals 8. And we'll combine these like terms here. Negative 14 plus 11y equals 8. Add 14 to both sides. 11y equals 22. Y is equal to 2, right? Divide by 11. Now again, right, we're not done. You got to find the x value. When you're using this substitution method, you're always going to have this equation here where you solved it for the other variable. Right, so that's always the one that I'm going to go back to and drop this y value, the one value that I found, into to find the other one. So this is x equals negative 7 plus 4y. If I put 2 in here for y, negative 7 plus 4 times 2, that's negative 7 plus 8, right? That's 1. And now I don't have my answer quite yet. I have all the parts, but I still have to put them together to get the final result. So my final result is going to be the point 1, 2. So when is this substitution method not necessarily a good choice? Right? I would not try to use the substitution method here. Right? And the reason is what I was talking about a little earlier. There is no variable that I can solve for without introducing fractions into the equation that are going to make things messy. You could do it. The substitution method will always work. Okay, but in situations like this, there's another method called the elimination method that we're going to talk about in the next lecture that I think is going to be the easier option.